Okay, so I'm going to talk about some of the performance analysis stuff that I've been doing with Parsl and with funcX and with some applications that have been using them recently. So Parsl has this monitoring system. It's kind of mature now, and what it looks like is there's live real-time updates that go into an SQL database, and then there's a web user interface, which is what this image is here. That you can query it with a bunch of predefined queries and graphs, and it pretty much just stores Parsl related data. So that's things like Parsl tasks, how many tries have happened, blocks going to your batch system, stuff like that. But in my time working with users on that, there are a number of buts have come up. So one but is, but there are other components. So for example, if you're running Parsl on top of WorkQ, the Parsl monitoring system isn't aware of what WorkQ is up to particularly, and WorkQ has a pretty nice log file called transaction.log, which talks about WorkQ workers, WorkQ tasks, which are not the same as Parsl tasks. I think there's a graphical UI for WorkQ as well, but I haven't touched that. Okay, we probably don't want to teach the core of Parsl about this kind of information. Because it's different for every executor layer. So if you're using HTEX, that has a very different structure of managers and workers and what a task looks like. And another component is usually now people run something pretty complex wrapped around Parsl, or if you're using funcX, wrapped around funcX. So some of the details of what's happening there can be useful for performance monitoring. So for LSST, for example, which Jim and David talked about, they've got these complicated spherical geometry things of putting patches and tracks on the celestial sphere and pointing the telescope at particular areas on that sphere. And sometimes for making performance related questions, we want to ask questions about the celestial sphere. I definitely do not want to teach core Parsl monitoring about geometry on a sphere at all. Okay, and the next but is that our users, or most of the users that I've worked with, are very well qualified in working with data. So this is not a downside, this is an upside. So probably most people at this event, you're not scared of analyzing data by writing code, which means you shouldn't be scared of analyzing performance data by writing code. It's just another form of data. And it tends to be that these same kind of users, that is you, like to ask interesting new questions. So both of those work fairly badly with this idea of having an easy to use web user interface with fixed plots and fixed queries. Almost anyone who's discovered the SQL database backing Parsl monitoring has wanted to just poke at the SQL database directly and pull it into Python. And the final but is that Parsl monitoring is trying to do sort of streaming data back to the central database, back to its submit side database in real time, so that when a job finishes, you right away you can see that status is updated. And that turns out to be really expensive in terms of latency. It's a lot of data being moved around that we have to store in one place if we're collecting it all. It makes failures really awkward to deal with. It slows everything down a bit, sometimes quite significantly. And if I'm doing, excuse me, I'm doing things like post-run performance analysis, I don't need that real-time stuff. I can run my workflow today. It will run for 24 hours. I can come back in a week's time, and I don't need that data live in one place. So I started thinking about a very different point in implementation space. So I'm going to concentrate on post-run analysis of performance data. I don't care about live real-time collection of data. I can collect it all afterwards from wherever it is. I want to be thinking about performance data from many components in the system in whatever format they fall out. So sometimes you get a nice SQL database from Parsl, or WorkQ gives this very readable, machine readable text format. Some other components just give you human readable log files and stuff like that. But I don't want to be forcing other components to change just so that I can query their data. I have to deal with them as they are. I'm expecting the users of this stuff to want to, and I'm expecting them to write their own queries in their own plots, probably for questions that are more ad hoc problem specific, rather than we've decided this is interesting information and that everyone will find useful. And I want to facilitate people using common tools. So the prototypes that I've built, I use Python, SQLite 3, Matplotlib. I'm not trying to constrain people to those. It would perfectly fit well in my head that you would run a query, export it to CSV, put it in Excel, and use your master spreadsheet skills to analyze data. That fits in perfectly well as well. So what do I think is going to come out of this work? Probably not a software product as a program or a service, but I think things like techniques, helper code, so some libraries to help import data and plot data, and maybe if I find there's easy changes I can make to components to make them friendlier, more amenable to this analysis. Maybe throw some PRs in there. I know that, for example, with funcX, I've done a reasonable amount of fiddling with logs there to try and make them a little bit more machine readable. So there's sort of this architecture. On the left is your application, which is built out of components, which are components of things like Parsl, work queue, whatever application specific stuff you have that understands your science domain, and they generate performance info, like I started doing this, I finished doing this, things like that. And I want to somehow pull it all in using some per component importers into a single data store. And then once it's all in that data store, I can ask queries that no matter where the data's come from, I can use similar looking queries. I don't have to learn new query languages and techniques. And I can also relate queries between things that happened in different components. So I built 2 prototypes. All of them have the ability in a very rudimentary way to pull data in from Parsl, from the monitoring database, from some fairly ugly log files, from work queue, from funcX. funcX has, if you're a funcX developer, you have access to these very nice admin-only JSON structured log files, which pull in very nicely. And my test applications just generate ad hoc log files. And the big difference between the prototypes was the first prototype was building an object graph in memory, so Python objects. So a Parsl task would be represented by a Python object. And that was very easy to then write plots and queries over that object graph using Python code. The performance was a bit icky there, so I tried out SQLite 3, which is my favorite small, large-scale SQL database at the moment. You can run queries in SQL, so they get very nicely optimized. Then whatever comes out of those, you can plot them in Python, and I'll show you an example in a minute. I've often found when I use the word SQL, people in this piece of academia seem to be very scared. You shouldn't be, it's just another language. So the little demo application I have is that I'm going to overload funcX by submitting as many 0 millisecond tasks as I can to funcX. And some piece of this is going to be the slowest piece. And I would like to discover which piece is going to be the slowest piece. So I have this code. This is my submitting code. You can imagine this is the code that knows what my science is, but all it's going to do is submit this no-op function to an endpoint and record the details. It's going to log out a line before submission, and it's going to log out a line when results have been retrieved for that task. And it has its own task numbering system from 3000 up to 3999. So one thing I'll point out here is that in the data model I'm using, there's a thing that the observability field calls a span, which is a unit of work. So you can informally imagine this to be like a task. But even in this little piece of code, there's two different things that are very similar that are tasks. So there's the numbered tasks, which is this iteration of the for loop, which just does a submit, but it might also do its own preparation work. And then separately, there's what happens when I submit using funcX.submit and I get back a future. So in some cases, that the first type of task will exist, but the funcX submit will fail, and the second type of task won't exist. So they're almost the same thing, but not quite the same thing. And throughout all the different models, all the different components, they all have very similar but different notions of what a task is. So for example, once I've run this code, a couple of seconds later, funcX will have submitted everything, allocated everything with a UID. And so then from the funcX central services perspective, that's when what the funcX purists would call a task really exists. And these other two things, this future object and the application level task, is a proto task or something, but it's not a real task. So it's important to understand there is subtlety there that is a little bit weird. So when I run that and then I import the results into a database, here's my SQL query and then a little matplotlib at the bottom, which plots a histogram. And basically I'm saying for every task that I submitted, do the end time minus the start time and bin that into a histogram. So I can see that tasks took between a couple of seconds up to 2 minutes to run, even though they're 0 milliseconds long. And if you want, you can make a guess as to why that is. Your guess is probably going to be wrong though. What I can also do is put my own timing into my worker function. So instead of just doing a no-op, I'm going to record the start and end time in there and return those. And so that's not real-time data. It's in an arbitrary format that I just made up for this code. And here I can see this graph scale is on 10 to the minus 5. So it's taking 10 microseconds to run. Very similar SQL, totally different plot. Okay. So those are what I regard as two different accounts of the same workflow. And what I'm interested in is how do you merge these accounts together? So I can say, well, tell me when it ended on the worker, how long did it take to, once my task ended on the worker, how long did it take for the result to get back to the submit time? So I have not put the query code in for this graph, but what this graph here is showing is that all the tasks ran in about 15 seconds, but the tasks that ran at the end, it was taking almost 2 minutes for the results to somehow get back from the worker back to my submit side. So what I initially thought was probably a task not running fast enough problem isn't that. It's something to do with the results coming back. And what I can do is bring in a third account, which uses my funcX admin access. And I can say, all right, split that plot into 2 steps. What's the worker to central services step and the central services to submit side step. And I can see that delay is happening somewhere between the worker and central services. And the central services to submit side is nice and fast, almost 0 for all of the results. So this was an ad hoc query, right? This isn't something that you would implement in a dashboard and release to all your users. It was just me exploring which bits were slow in the funcX task execution cycle, and then trying to zero in a little bit more. And eventually we found the function call that is causing the slowness here. So if I was to do this again, if we change the code, I wouldn't be using these queries. I would be doing the same kind of attack on funcX, but I would be led down a different path to find a different slowness. Okay, so that's an argument for not having prepackaged dashboard queries. being able to do exploratory stuff, easily add in more data. So that's kind of where I've gone. It's all very prototypey, hacky Python code at the moment. I would like to get something that looks like a GitHub repo that people can play with. And then in the future, lots of the non-goals that I said earlier on could be future work. Maybe people do want to build dashboards. Maybe people do want real-time updates. There's lots of messing around with the database representation, and everyone, whenever I talk about monitoring, people always ask about provenance, but never really engage with me on it. But there's definitely some relationship there. And there's a lot of work to be done just tidying logs and things up to say, use more machine readable stuff rather than human readable strings. Okay, so I'll end there because I think my time is up. Okay, any questions?
I'll do one. So if there's, do you ever run into situations where you have scaling problems with SQLite in the like database side? Like, you mentioned you're doing, sometimes you're doing the real-time streaming of
yeah, so the one thing that I found SQLite really bad at is having multiple people accessing it.
Right.
So a massive problem with Parsl monitoring is when you try and run a big SQL query that's on a run that is running, then Parsl can't access the database to store that data. It kind of backs up in a big queue and sometimes explodes because SQLite 3 isn't really designed for multiple connections, multiple uses.
Have you thought about something like LMDB for that? Something where it's more like performant?
Yeah, so the direction that I moved in for this was just moving into not doing real-time stuff.
Got it.
I think there's definitely scope for, if you're doing real-time, putting some different thought into what that database architecture should look like. So I think this present style is just, well, what we built to begin with works well enough. There's not enough to motivate us changing it to something else. I don't think we're ideologically tied into it particularly.
Thanks, Ben.
Have you coordinated or spoken to Radical, WorkQ, etc., about this sort of generalizable model? Would there be buy-in?
I've talked to Doug a little bit about it, not a huge amount. Yeah, I'm behind on this project. I was hoping a few months ago to have some code in GitHub which I could give to people rather than it being my vague ramblings. But I got distracted with other things.
All right. Thanks, Ben.